Hey folks, it is Lee from the Upper Darby Township Library. I am here with this afternoon's STEM Shenanigans program, and we are going to be playing with static electricity today. So let's start by talking about what on earth causes static electricity. So, do you guys remember in science class where we talked about like atoms and how atoms are made up of three basic building blocks: protons, neutrons, and electrons, right? And two of those have an electrical charge, right? Protons have a positive charge, and electrons have a negative charge, and neutrons are neutral, just like they sound. So atoms tend to hang on to their protons and their neutrons, but electrons can move from atom to atom, and that is what causes static electricity. When electrons um, move from atom to atom because something rubs up against something or touches up against something else. And so you know how like if you rub a balloon against your hair and your hair all stands up, that's because there's electrons moving from from your head to the balloon and vice versa. And that's interesting because it builds up the same kind of charge because it goes back and forth. And so that's why your hair tends to stand up and like stick to the balloon because they have the same charge. But if all the electrons move from one thing to another, like if you shock your friend, that is all the electrons moving from one thing to another. So like if you like rub your feet on the rug and you build up a bunch of electrons in yourself, and then you touch your friend or you touch like a door or something like that, like a piece of metal, and a shock happens, that is the electrons moving from you that built up in you to the other thing, right? So those are the different sort of causes and effects of static electricity. And what we're going to do today is measure how like different materials pick up static electricity or don't, right? And so what we're going to start with is building a homemade electroscope so that we can measure the static electricity. So if you have your kit, you have some really random materials. If you don't have a kit, you can come to Sellers or Primus libraries anytime. We're open. There's still some kits left over, so you can watch this video later or just remember what we did and do it yourself later. But if you already have a kit, let's go over what you have. You have an aluminum pan, right? And so one of the things that we know, right, is that metal is a really good conductor of electricity, right? That's like pretty basic, right? Metal and water are really good conductors of electricity. So we're not going to worry about like testing that, right? We know that. You've got a styrofoam tray or a plate maybe. You've got a styrofoam cup and a straw, and you've got a little container with a balloon and a string in it, and you've got 4 sheets of different materials. You've got foil, you've got parchment paper, you've got plastic wrap, which is kind of my nemesis, but we're going to use it anyway, and you've got felt. All right, so we're going to test the parchment paper, the plastic wrap, and the felt to see how they conduct electricity and see which conducts more or less electricity than the others. Some things you're going to need from home that I didn't put in the kit include a pen or a pencil for 2 reasons. One is poking a hole in the cup to put the straw through as we make our electroscope. You're going to need, and also to write down your results of our experiments. So that's the 2 reasons you need a pen or a pencil. You're going to need a ruler, and you're probably going to want either a wooden or a plastic ruler. Actually, probably a wooden ruler if you've got one. You can use your measuring tape if you need to. If you've got like a plastic measuring tape or a cloth one, that's best. You kind of want to avoid using like a metal ruler or measuring tape if you can, simply because it's going to conduct the electricity instead of letting it stay where it is, if that makes sense. But we're going to use this to measure the extent to which our electroscope, registers a charge. And you're also just going to need some tape. Doesn't matter what kind of tape, you're just going to use it to tape your electroscope together. All right, so just anything that's going to hold like some light materials together that are not going to be like under huge duress. So masking tape, Scotch tape is probably fine if that's what you've got. If duct tape is all you've got, whatever, painter's tape, doesn't matter, right? Just some tape. And please forgive me, I have a cold, I'm okay, but if I'm sniffling or have to wipe my nose or have a cough drop, that's fine. All right, so we're gonna start by making our electroscope. Okay, so we are gonna start by, so the way it's gonna work is that what we're gonna do, and you also wanna be on a surface that's not made out of metal, right? So I'm on a plastic table, you can be on a wooden table, plastic, that's fine, just not a metal surface. So if all you have is like a metal desk, then probably be on the floor. Okay, so the way this is gonna work is that this is gonna be the base of our electroscope, and this cup is gonna get taped into it, and then we're gonna put the straw through the cup and hang the string with a ball of aluminum foil so that it just touches the edge of the tray, okay? So we'll do that. All right, so I'm gonna start by poking a hole in my cup, okay? And I want it to go all the way through so that my straw can go all the way through, okay? So I've got a hole on one side, and I'm just gonna keep poking all the way through. And like fairly near the top, so that, you know, you've got some string to hang down, okay? And so now I'm gonna poke my straw through. Okay. All right, awesome, cool. And if you find that your pen or pencil is like way bigger than the straw for whatever reason, and your straw is like real loosey-goosey in there, you can tape it so that it doesn't move a whole lot. All right. Okay, so now I need my string. We'll use our balloon in a few minutes. All right, I need my string, and what I'm gonna do is tie a knot tie it around the straw. And again, like if you can't get it real tight, and it seems like it's real loose and wants to slide back and forth, you can tape it on there, that's fine. I'm just gonna start by tying a knot. All right, cool. So then we've actually probably got more aluminum foil than we need, because you don't want it to be too heavy, because then it's gonna just be like too much of a lift for the electricity to be able to register very well. So I'm gonna like use like a quarter of this. And if it still seems too heavy once we test it out, then I might use like a smaller piece. You've got plenty to work with, don't worry. All right, so I'm just gonna sort of, you want it to be about the size of a marble, and it doesn't have to be like super like tightly mushed together, because again, you want it to be pretty light. The point is not for it to be a heavy thing, the point is just for it to be like a thing of metal that you can use, right? Okay, so you're just gonna like wrap it like around the string a bit. Wrap it and the string sort of around each other so that it stays on there. That's pretty good. Okay, cool. So, and I'm just gonna adjust it so that it just touches. All right, so I don't know if you can see that. I'm gonna move it so you can. All right, so we've got that, so it's just touching, just barely touching. And so I'm gonna tape the cup in place so that it doesn't move as we're doing our experiments, all right? And again, if I happen to move the cup while I'm doing this taping procedure, that's fine, because I can just adjust my string so that it's back where I need it to be. No big deal. I'm really excited about the fact that we can use this wild looking like homemade, you know, robot kind of looking thing and measure electricity. Like, how cool is that? All right, so again, it's just sort of lightly touching there. I think we're in good shape. Cup doesn't want to go anywhere. It's all good. I'm going to tape it one more time, 2 more times, just around the other 2 sides, because one of the things that we're going to have to remember is that we're going to actually pick this up by the cup. So I actually do want it to be pretty well in there. So I am going to tape it a little bit better. Again, I don't think that this means you need like super hardcore tape. I think it's going to be fine. It's all very lightweight. You know, I don't recommend like trying to throw it across the room and not fall, you know, not have it fall apart. But I don't think you're going to need to do that. So no big deal. All right, so let's just tape this guy one more time. And the reason that we're going to pick it up with the cup is that styrofoam is an insulator, right? And what we don't want to do is like discharge any of the static electricity that we're trying to measure by touching the metal, right? We want to be able to hold in as much electricity in whatever material we're handling as possible until we're ready to measure it, right? Okay, so I am going to blow up my balloon. Just going to stretch it out because sometimes I embarrass myself trying to blow up a balloon. Don't act like you haven't done that before. Oh, for crying out loud. I'm going to get it a little bit bigger. It doesn't have to be huge, but I'm going to get it a little bit bigger. All right, there we go. Good enough. So, I'm just going to tie a knot here. So I have a blown up balloon. All right. So, first, we just want to make sure that our electroscope is working. All right. And I am just going to, for fun, do this on my head just to sort of say like, all right, you know, there's some static electricity in this room and it is working as advertised. Yep, there we go. Just as anticipated. All right, cool. So the first thing that we're going to do is I'm going to rub these two things together to see if we can build up some static electricity in the styrofoam plate, and then watch it work. Watch the electroscope do its thing. So you want to rub these together about 20 times. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, I'm going to put it down. And then put this on top of it. That didn't do anything. I wonder why not. Whoa, but it did try to stick together. Whoa, that's cool. Interesting, though, that it didn't... Oh. Huh. So my finger... so a couple of interesting things happened here, right? One, these stuck together, which means that they were similarly charged. But this didn't register anything. But my finger did sort of make this move away from here. So it was picking up on something, but it's like the electricity was in me and not this. So here's what I'm going to try doing next, actually. Is I'm going to see if I can rub this on here and then leave it where it is instead of picking it up and moving it around. Because I think maybe all the static electricity went into me instead of the styrofoam. All right, let's see if that works. Again, these things are similarly charged. Interesting. So I'm going to read some of my instructions a little bit and see if there's something that I'm doing wrong, because that's totally possible. So interestingly, that basically I did everything right. Let's move on and see what happens next, okay? Let's try some of these other things, all right? Yeah, let's just see. So one of the things that is interesting about the rubbing that I didn't realize before I started looking into this to do this program was that it's not so much about the movement that makes the electrons go back and forth. It's actually just that you're creating more and more points of contact, but like without letting it discharge. So yeah, so it's actually not the movement so much as just the like number of points of contact. So that's interesting. All right, so the way we're gonna use this, and again, we'll see if this works, right? The way we're gonna use this is that we're gonna rub a material, and I'm gonna start with the plastic wrap because I feel like anybody who's tried to use cling wrap knows that this stuff builds static electricity. So let's give it a shot, right? Man, this stuff is still just very stuck together. It's so interesting. It like has, I mean, I guess it's staying close because it has a similar charge, right? Anyway, so the way we're gonna do this is that we're gonna rub the material on the balloon and then put it on the styrofoam because that's a good insulator, and then put the electroscope on it, okay? So let's see how this works. Oh Lord. I'm telling you, me and cling wrap are not friends, but we are gonna work this out. So again, you wanna rub it about 20 times. Okay, I feel like this stuff, I can tell, is full of static electricity because it's trying to stick to me. All right. So, interestingly, it's still not like registering the charge from below. I am gonna try something different, actually, because I'm wondering if it's my pan, if somehow my pan is made out of a material that's not working very well. And I know that my tin foil, my aluminum foil, is registering because it keeps reacting to my finger as it moves. So I am gonna be right back. What I'm gonna do is actually get a bigger sheet of foil and use that as my base. I'm gonna take off the pan and use that as my base and see if that works better. So I'll be right back. Hang tight for just a second, because I can tell just by like the way that this is acting, right? Like it's full of static electricity, or it was, right? It has discharged itself now. But it was full of electricity. It was sticking to itself. It was sticking to me, like it was definitely acting as though there was electricity in there, but it didn't register in the electroscope. So let's see if a different base will work. Be right back. Okay, so I've got foil, and we're going to use this. All right, so basically what I'm going to do is take my cup and take it off of this base and tape it to the foil. And rig it up somehow so that these two pieces of metal are touching one another. So I think what I can do here is just make like a rim here, some kind of way. Yeah, that'll work. Okay. So those are touching. Just touching. All right, so let's try this now. Let's see what happens now. All right, let's start again with our simple styrofoam base. And I'm gonna rub this balloon on it. All right, let's see. Let's see what we get. Still nothing. Interesting. But again, it's sticking to it. This is so interesting. Wait a second. Is it? No, I think that was just me holding it strangely. Okay. So they definitely have like a similar charge. And I wonder, Yeah, no, okay, all right. Well, let's try again with our plastic wrap, okay? And see what happens. Okay. Interesting. It's still not happening. I'm gonna try a different material and see what happens then. I wonder what would happen. I'm gonna try something different. I'm gonna try placing it on top of this guy instead and see if that does anything different. So interesting. All right, we're going to move on. And it might be that what we learned today is that homemade electroscopes don't work as well as we want them to. And then we still learned something, just not what we were thinking that we were going to learn. That's all right. All right, so we're going to use felt now, okay? So this is maybe wool, but probably acrylic. Felt is made out of lots of different things. Sometimes natural materials, frequently not. This one I suspect is not. Interesting. Okay, so that definitely didn't, I mean, you know, any more than any of the rest of these have. So let's try it the other way, the way that we're, you know, supposed to do it. And we'll put it on our styrofoam here. And again, the reason for the styrofoam is that it's a good insulator. And so it's not gonna let the electricity go anywhere. It's like gonna keep it in the object is the goal there. So let's try this again. Still nothing. I'm gonna try something different. I'm gonna try rubbing this on my head again, and then I'm gonna try touching the balloon and or my finger to the metal and see what happens then. See if we get a see if that registers anything. Oh my God, it's making my hair crackle. All right, so we've got plenty of static electricity built up. Yeah, so interesting. I would say that it did not really register anything. I mean, I think so it's attracted to one another, which tells me that they're having sort of the same charge. So one of the things that I know about this experiment that I didn't think about until just this moment is that apparently it's harder to do on humid days. Now, why might that be? Well, what did we talk about in the beginning is a good conductor. Two things, metal and water. So I'm wondering if there's enough moisture in the air, because if you look outside, it's a pretty gray, humid day. I'm wondering if there's enough water and moisture in the air that it's sort of conducting the electricity around the room and not allowing it to build up and stay in any one place. That's just a guess. We're gonna keep going and see what else we can do. We have one more material to test. It's parchment paper. But that's my guess as to why this isn't working the way that we're expecting it to, why instead it's seeming like our electroscope has the same charge as everything else, why it's sticking to everything instead of repelling. That's my guess, that it's humid enough today that the electricity is just moving through the air. But we'll see. We'll see if we can get any kind of reaction from this. And also, if anybody watching has any ideas about something that I'm doing wrong, I would love to hear your ideas. sort of caught on the string. All right, let me try that again, because I feel like the string was sort of caught, and I want to make sure that what I'm seeing is an accurate reflection of any movement or lack thereof. And also, if you're getting different results at home, I would love to hear about it. I would love to hear if you're doing anything a little bit differently. All right, so this is sticking to me. So there's definitely some static built up in there. It's sticking to the styrofoam. Yeah, and the only thing that's happening is that this is sort of like, oh, wow. Whoa! I don't know if you, can you see? It's like moving back and forth between me and, I can't tell if you can see that or not. You probably can't. But it was like moving back and forth between me and the piece of metal here. That was wild. Yeah, that was cool. So I guess it was in some ways sort of repelled, but it seemed like it was more about gravity. Excuse me. Having an issue there. I'm gonna try something a little bit different this time, because I think part of what's happening is that because I traded my slightly heavier base over there for a lighter base, we're getting some tiltage happening, which is maybe causing some gravity to affect our electroscope. So I'm going to try that again, but I'm going to angle this a different way that I think will be less affected by gravity. So we'll see if that makes any difference. So many variables that we didn't anticipate. Yeah, it makes experiments so complicated, doesn't it? And yet so cool. All right. So I'm going to do it this way this time. You can still see it, but I think it's going to be... Oh yeah, can you see it doing its thing now? It was like moving back and forth. It was definitely repelled from that, but like only by like a centimeter or so. So there was a little bit of static electricity that we could measure there, but isn't that cool? It's like sort of attracted to my finger and then bounces off. So interesting. All right, let's see. I'm gonna try a tissue because I have a box of tissues right off camera. Let's see if we get anything different from a tissue. All right. So interesting. It's really kind of hard to tell what's gravity and what's electricity in terms of what's moving this thing. But it is definitely, you know, this thing shifted once when I moved the rim here. I don't know if you quite caught that because it was pretty small. But when I moved the rim here to make them touch again, the ball shifted so that it would stay about a centimeter away. That's real. I feel like I'm talking about haunted houses or something. This was like spooky. But no, like that's real. Like that's not about the string getting in the way. That's not about gravity. That's about the fact that this ball is registering that like 1, centimeter or so worth of electricity. All right, cool. I'm gonna try, now that I'm like sort of seeing it more now, and maybe it was just a matter of recognizing these teeny tiny shifts, and I'm not chalking it up to gravity anymore. I'm gonna go back through our materials. I'm gonna go ahead and measure this, just so I'm not like, eyeballing it and calling it a centimeter, but like see how far it actually is away with my tiny ruler. All right, that is, let's see, this is only measured in inches. So that is, I would say, 1/8 of an inch. 1/8 of an inch with the tissue. All right, so I'm gonna write that down on my little piece of paper. Tissue. ⅛ inch. Cool. All right, so let's try our plastic wrap again. My old nemesis. But see, like that's sitting totally differently. Like that's sitting inside it, but it was like definitely like holding itself 1/8 of an inch outside of it. So cool. All right, here we go. Nope. Nothing. Nope. So interesting. I really expected that to have a reaction, but it didn't. Again, could be the humidity, I suppose. I don't know. I would love to hear your thoughts about why you think this is happening. I'm gonna try, why not? I'm gonna try the other bit of tinfoil. Okay. No. Wow. So the tissue really was the most reaction that we got, which is interesting. Yeah, I don't know really what to chalk that up to. I'm gonna try, I'm just gonna rub this thing on everything. Nope. So interesting. I'm gonna do it on the table. Oh, you know what? That's not gonna work because this is sitting on the table. Let's try this. quite possibly just too many things are touching the table for this to build up very much electricity. So let's find out. Let's try the balloon. No. All right, well, I think what we learned here today are that electroscopes are tricky things to make. Humidity plays a huge part in testing static electricity. It is easier to visualize the effects of static electricity than it is to measure them with a homemade electroscope. Yeah, those are the things that I feel like I learned today. If you learned different things, I want to hear about it. If your experiments at home went differently, I want to hear about it. If your experiments at home went the same, I want to hear about it. I hope that you enjoyed this, regardless of the fact that it did not go as expected. I feel like we learned some things anyway. And thank you for joining me for STEM Shenanigans. This, my friends, is why we call it Shenanigans, because who knows how it's going to go, really. We'll see you back next month on the 4th Thursday of the month for STEM Shenanigans, and enjoy.